Lesson 29 in Algebra 1 is called Negative Exponents. And there's two topics in this lesson. As usual, we're going to take one topic and just try to break it down so that there's not too much information in any one lesson. Now, before we talk about negative exponents, let's review what we've already had. What you see below, I have 2 cubed. Now let's think about what 2 cubed means. 2 cubed means 2 times 2 times 2. And I would get a product of 8 on that. Now we've also had some examples where I might have a number in parentheses, such as I have below. And remember, when you have the parentheses, in this case, you're going to cube whatever's in the parentheses. So this means a negative 2 times a negative 2 times a negative 2, which is a negative 8. As we've emphasized before, this one, and for example, if I wrote this, these mean two totally different things. Now, it might be by coincidence that you may get the same answer on these two, but also at other times you won't get the same answer, so it's important to understand the difference between the two. Now, in this example, since you don't have parentheses, you're going to cube the 2, which is 8, and then take the opposite of that. And notice that we did get the same answer in these two, but only by coincidence. So it's important to know the difference. When you have parentheses, you take whatever the exponent is to that power. When you don't have parentheses, for example, in this case, you're going to cube the 2, then take the opposite. Now, something I want to emphasize on all these examples, notice that in all these examples that the exponents were always positive. So in all these 3 examples, the exponents were always positive. So that's something that I want you to keep in mind. Let's take a look at what's meant by the definition of x to the negative n. Now, we're going to start talking about negative exponents, but before we do that, let's take a look at this definition. And I'd like you to write this down in your notebooks. Whenever a number or a value is taken to a negative exponent, we can't simplify it, and we really can't work with it. So before I go over the rest of the definition, we know that from my previous example that 2 cubed, that's 8, right? 2 times 2 times 2. But what would happen if I took 2 to the negative 3 power? How would we handle that? And you can't say that's 8, and you really can't say it's a negative 8. We don't know. So that's what we're going to take a look at this definition then. Anytime we have a base to a negative exponent, we can rewrite that or work with it or simplify it by simply forcing the negative exponent to become positive. And how we do that is, notice this x to the negative n. It's really, we could write that whole thing over 1. But we can force that negative exponent to become positive if we take this whole thing and we move it down, as they did here. And what happens then, instead of x to the negative n, it becomes x to the positive n. That's the definition of x to the negative n. Now let's simplify this up. The best way to simplify this up is to actually go through some examples. And you can see that this is going to clear itself up and become pretty easy, I believe. So in example 1, we have 3 to the negative 2 power. Now, I have a negative exponent. We can't treat this as like that, or in other words, 9. Whenever we have a negative exponent, we got to think to ourselves, well, we got to modify this problem such that I can work with the exponent. So what we're going to do is, I know that my exponent is negative, and really, this problem means this. So what I'm going to do is I'm going to take this whole thing and I'm going to move it down below. And in doing so, that forces the negative exponent to become positive. Now, what's left up above? Well, there's got to be something, and that's a 1. We have a value of 1 left. When we move something up or down, 1 is left. The value of 1 is left in the top. Now I can see that this is easy to simplify. So my answer is 1 over 3 squared, or 1 over 9. So 3 to the negative 2 is equal to 1/9. Now let's use the same method as we did in example 1 on example 2. Now this time the negative exponent is down below. All right, so what we're going to do is, since this whole thing is down below, we're going to move this whole thing up. So it becomes 3 in parentheses cubed. What's left down below? 1. Now I can simplify this. 3 cubed, 3 times 3 times 3, is 27 over 1, or in other words, just 27. So you're starting to see here, when I have that negative exponent in the top, I'm going to move it down below, or downstairs. If that negative exponent's down below or downstairs like it is here, I'm going to move it upstairs to force that negative exponent to become positive. Let's take a look at example 3. Now I'm thinking that this means the same thing as this. So that negative exponent is upstairs. Alright, I'm going to move everything downstairs. Now when I do this, whatever's in parentheses stays the same. That doesn't change, it stays the same. But what does change, and what you got to remember, is that negative exponent is forced to become positive. And remember, 1's left in the top. Now I can simplify that, because the negative 3 times the negative 3, remember you're going to square what's in parentheses, negative 3 times negative 3, and I get 1/9 then. Alright, example 4. The negative exponent's down below, so what are we going to do? We're going to move everything up. So the 2 stays 2, but it's to the positive 3 power. And what's left is 1. Now I'll simplify that, so 2 times 2 times 2 is 8 over 1, or in other words, 8 is what this simplifies to. Alright, the final example I have is utilizing some negative exponents also. Now we've had expressions like this before. So in other words, everything's multiplication. And just to review this a little bit, remember how you multiply powers? So if I had a squared times a cubed, remember you add the exponents, and so that's a to the 5th. Well, we're going to use that same process down below. So remember, you can group your x's together. You can change the order that you're multiplying, if you want to. You don't have to do that. So I have m squared times m to the negative 5. Now I'm going to multiply my powers. So x to the, let's see, 4 plus a negative 2 is 2. Now I'll do my m's. Add the exponents, 2 plus a negative 5, or 2 take away 5. You could think of that, both ways. When you multiply powers, you add the exponents. 2 plus a negative 5, or 2 minus 5, it means the same thing, and you get a negative 3 out of that. So the only new thing here is that we're dealing with negative exponents when you're adding those powers, those exponents. Now, I have a final answer of this. Now, suppose that I wanted you to write this answer, the final answer, with all positive exponents. Think about how you do that. How could I write that answer, this answer right here, with all positive exponents? Well, the x squared, the 2 is positive, isn't it? So I'm going to leave it on top. So I'm thinking that this right here is the same thing over 1, right? So I'm going to leave the x squared in the top because the exponent's positive, but I'm going to bring this down below and force that negative exponent to become positive, and it becomes m cubed. So really, these two answers mean the same, but one is written with all positive exponents and the other one has a negative exponent in it. So I can, and I could even write it like this. How about if they wanted you to write the answer with all negative exponents? What would you do? Well, let's see. This is already negative. Leave it in the top. Move this down. So I would have m to the negative 3 over x to the negative 2. So you can manipulate the way that you write this depending on what the directions are for that particular problem. I wouldn't think into that too much for right now, just so that you realize that when you're multiplying powers, you add the exponents. So, the beginning topic in lesson 29 is negative exponents.